Hi, I'm Matt, a chemistry scientist at the University of Sheffield. I research, and that means that I find, make and learn new things that no one has before. I made this molecule which only exists inside of my lab. How cool is that? And that's why I love science, because finding, making and learning new things means that I get to change the world. My research is in figuring out how chemical reactions occur. You'll learn a bit more about chemical reactions in our next video, along with how to make slime, bath bombs, and your own Buckyball molecule. But first, we have a problem. How big are these things? Scientists compare everything's length to a meter. How big is a meter? That big? That big? Well, we need to be more exact if we're going to be scientists, so we use rulers. This is a meter ruler, and it's made up of 100 centimeters or 1,000 millimeters. But in science, we measure things much, much bigger than a meter and much, much smaller. What are some of the biggest and some of the smallest things you can think of?
An elephant, a house, the Eiffel Tower, the world, an ant, a grape, a mouse, a germ.
Those are some great suggestions, but in science we work with things even bigger and even smaller than those. So it's really important for us to have a way of describing how big things are compared to each other, and that's called scale. So the sun is pretty big. As a matter of fact, it's 1 billion meters in diameter, which means it would take 1 billion of you stacked on top of each other to reach the size of the sun. But just how big is a billion? Well, I'll write it down. That's really big. Now the Buckyball, which you'll learn about in the next video, is much, much smaller. As a matter of fact, it's 1 billion times smaller than you are. So to write that out, that's really small. As a matter of fact, you compared to the Buckyball is about the same as the sun compared to you, and it's much smaller than an ant or a germ. Now as scientists are really busy, and it gets really tiring writing out all of these zeros. So we've come up with a quick way of writing them. So for really big numbers, like for the sun, we take the first number and then count the number of numbers between it and the decimal place. So 1, 2, 3, 4, 5, 6, 7, 8, 9, which means this is equal to 1 times 10 to the 9 meters. For small numbers like the Buckyball, we count the number of zeros before the first number. So here it's 1, 2, 3, 4, 5, 6, 7, 8, 9. And because it's small, we write minus. So it's equal to 1 times 10 to the minus 9 meters. So this minus 9 means that there are 9 zeros before the first number. Now over the years, scientists have made it even easier by coming up with nicknames for some of these numbers. Picometers, nanometers, millimeters, kilometers, gigameters, terameters. Notice that the bigger the number, the cooler sounding its nickname is. So now you know a bit more about how we compare big things and small things. So let's see how good you are at finding the right place for things on the scientific scale. That's you in the middle. So where do you think the Eiffel Tower would be on the scale? Yep. What about the sun? Excellent. Now where do you think a mouse would be? That's right. And what about the Buckyball? Great. As you can see, everything has its place on the scientific scale, and it can be extended even further than what we've looked at. Astronomers look deep into the night sky and look at stars much, much bigger than our own sun, and galaxies made of billions of different stars. On the other end of the scale, scientists like me look at the smallest things which make up everything, atoms, also known as elements. There's over 100 different types, and you can find them on the periodic table. They can be joined together to form molecules in all different shapes and sizes, like the Buckyball, which you'll learn about. So the key things to remember are that scientists look at really big things and really small things, and we use different units of measurement depending on where they fall on the scientific scale. All of these units are compared against the meter, and we use words as shortcuts to save us writing down lots of zeros. We hope you've had fun learning about the scientific scale. Now you know all about where molecules fit on it. Why not check out our next 2 videos on how to build your own Buckyball molecule and how to use chemical reactions between molecules to make new substances like polymer slime and bath bombs.